Hey guys, welcome back. This will be the final video for section 1.1 and you're going to see how beautiful it comes together. This is actually so wonderful. You're going to see why we talked about M equations and needing n variables, the same amount, free variables, and so on. And again, to get the most out of these videos, be sure to pay attention to the minor details because they are actually really a major part of the course. So to sum up section 1.1, we're going to talk about having no solutions and having infinitely many solutions. Okay, so an inconsistent system is one that has no solutions. In this example, I'm going to show you why this has no solutions. Once again, our goal is to have that row echelon. We want the ones in here, here, and here, the leading coefficients, okay? So I'm fine here. What I'm going to do is I'm going to multiply the first by -2 because I want to combine it to the second. Our goal is to get a 0 right here, okay? Our goal is to get a 0 right here and here, okay? Those are our goals. So I'm going to multiply the first by a -2, and then I'm going to combine it. So what would happen if I multiply by a -2? This will be -2x1, positive 6x2, -2x3 equals -2. When I go to rewrite this, even though I'm multiplying -2 to this, I'm not changing the first row. I'm multiplying the row by a -2 so I can combine it with the second row. So I'm going to keep the first row as is, okay? And then -2 plus this is 0. 6 and -1 is 5. -2 and -2 is -4. And -2 and 2 makes 0, okay? Leave the second one, and now leave this person here. So I'm going to go x1 plus 2x2 minus 3x3 equals -1. Now you have to be very, very careful with your algebra, everybody. So I want a 0 here. This looks really good. I'm just going to subtract the 2. Now, some of you might say, wait, we could just subtract? Sure, because subtraction means multiplying by a -1 and then combining. So once again, I'm going to recopy the first, the second, and now negative. So I'm just going to subtract this minus this disappears. -3x2 minus 2 makes -5x2. And then -x3 minus 3 is going to make -4. And then 1 minus -1 makes 2. Okay? Let me just make sure. I think this negative should be a positive. It should be a positive. Okay? So you're just subtracting. Okay? That's why I multiply by a negative, but I'm just subtracting. This minus this is 0. This minus this is -5. This minus this is +4. Great. If you take a look at these two, well, if you take the negation of the third one, what you're going to notice is something that I discussed in video 2, I believe. And what that was when we were talking about parallel. Let me just put this here. Come on. Okay. If I multiply this whole thing by a negative, let's just say, because you can multiply by any number, right? This will become a positive, this will become a negative, and this will become a negative. Do you guys recall from video 2 that if we have the same numbers but different y-intercepts, that they won't have any solution? So you don't get any solution here, okay? So if I go back, you can stop right there and say there's no solution because they match perfectly. It's like two parallel lines. But if you go back and keep it like this, now you can say, okay, I know I need this to be 0, so I'm going to just take the second and third equation and combine. So I'm going to leave this alone, and when you go to combine this, that's 0, and that's 0, and that's actually 2. So when you take a look at this, how could 0 equal 2? It can't. When you get something like that, it's inconsistent, there's no solution. Or, guys, if you notice right away that these are identical, the number in the front of x2 and x3 are identical to the one right below it, you know you can stop, there's no solution. And I know right now they're not identical, but you can just multiply by a negative because that's one of the operations. So this is called no solution inconsistent system, okay? So if anything matches but you have different numbers, it's like parallel lines, they're inconsistent. In this final example, we're going to take a look at a system of equations where we are going to have infinitely many solutions. So what we want to do again is to get into row echelon form. And first thing I'm going to do is I'm going to interchange these two, okay? So that way we can have the 1 right here. And we're going to swap this because this is great because, let me just write this down, because now we have a 1 here and we have the 0 here that we want. And then we have the third. Now the problem here is you just have to be very careful with the algebra. I made a ton of mistakes. Okay, what we're going to do here is we're going to combine the first and the third in order to make the third. So I'm going to have x1 minus 3x3 equals negative 1, x2 minus x3 equals 0. This plus this makes 0. This plus this makes 3x2. This plus this just leaves you with this, and this plus this gives you 0. Now, if you basically multiply the entire third row by 1 over 3, okay, so I'm going to take that to the next page. So please bear with me as I copy this. Copy, next page. Okay. What we can have here now, thank you, is x1 minus 3x3 equals negative 1, x2 minus x3 equals 0, and then x2 minus x3 equals 0. These two are identical, right? And so in that case, what's going to happen here is that let's just combine this for a second. Okay, so if you combine the second and the third to give you the third, we're going to have that, and then this plus, subtract these. This minus this is 0, x2, which is just 0. This minus this is 0, x3. This and this will give you 0. So basically you have zeros here, which means the entire third equation is gone, right? So that's what that basically means. Now, we have x1, we have x2, we have x3. We have 3 variables. In the previous video, I've spoken about basically if you have 3 variables, that means you need 3 equations in order to solve. But because I only have 2 equations, that's the M that I was referring to earlier. 2 equations, 3 variables, that is when you are basically going to have infinitely many solutions. So we're going to just get rid of this because this no longer exists, okay? And what we're going to do here is we're going to say let x2 equal x3. By just adding this to the other side, we're just like assuming it right now. But basically, let x3 equal t. That makes x2 equal t. And then x1, everyone, if you add this to the other side, would be 3t minus 1. And here's our parametric representation. But the most important thing is that we basically have 3 variables and only 2 equations, which means that we can just assign, we're going to have infinitely many solutions. We can assign t, let's say 7, that makes this 7, that makes this 20, and so on. So that's how we come up with finding our infinitely many solutions. And then once again, With the inconsistent solutions, we're going to have where it's sort of parallel with different constants, okay? So these are called coefficients, the numbers in the front, these are called constants. So I hope you enjoy